Okay, so what's different on this here is that we have a table or a graph that we need to put our points on that is not labeled. So you have to label it. Okay, so hopefully you've done some of this before, and if not, we're going to talk about it. So starting with the length, we'll put our length down here. And the length is in inches. And then we're going to do our weight on the side. This should say, but it doesn't. It's in pounds. Feel free to abbreviate. What's the abbreviation for pounds? LDS. So what we want to do is we want to label our sides. So we're going to take a look at our largest number and our smallest number. These are in order. They won't always be in order. So our largest number is 72 for our length, and our smallest number is 60. So we're going to take 72 minus 60, and we're going to divide by the number of slat marks we have there. Some number of places where we can put a number. So how many are there? Count them. 16. Okay, so we're going to divide this answer by 16. So it gives us 12 divided by 16, which is 7.75. Thank you. So we don't want to go by 0.75, so we're going to round that up to 1. So we're going to go by ones. So we're going to start with a length of 60 and then go by 1. So 60. Just because I don't want to label all of them, I'm going to skip. You can go 60, 61, 62, and so on. I'm just going to skip and do 62, 64, 66, 68, 70, 72, and I think 72 is the largest number, so we're good there. Okay, so I'm going to erase this and do the same for the weight. What is the highest weight? 158. And we subtract the lowest weight, which is 105. And then we divide again. It's 16 different numbers here. So we're going to and so we get a 3.3125. So what would we round that to? Usually it's better to round up. We're going to, but it's easier, but we like it to be, sorry, I need to explain why we're doing this. So we want to do this because we want our graph to be as big as possible. If we make our increments just like a couple increments over here, so say we counted from 105 to 158 right here, then everything is going to be bunched up in this little corner here, and it's going to be hard for us to draw a line of best fit, and it's not going to be very accurate. So we want it to be very accurate. So what we want to do is we want to make it as big as possible. Yes, Brooklyn? So there are 16, if you count these here, 1, 2, 3, 4, 5, 16 different places to put numbers. Yeah, on your graph. So this is the first time you've had one that hasn't been labeled for you. So we're going to go by threes, and we're going to, because we're going down, we know we're going to go off the graph a little bit, and that's okay. So let's start with the lowest number, which is 105. And then so going by threes, it's easier if I label all of them. And then we go up to 156. So questions on what I did there? Okay. So I'm going to erase this, and now we're going to draw our points on the graph. So 60, 105 is, let's do that in red. 60, 105 would be right here. 62, 114. 64, 124. 66, 131. 68, 139. 70, 149. And 72, 158. It's going to be up here. So now we want to draw our line of best fit. So on that line, you've got to use your ruler. Here that you use that ruler, and you want that line to be as close to those points as possible. Start over again. So these are pretty darn close, these points here. So I could go up here. What do you think about that line? No, not good, because it's too far away from the other points. So maybe about there. Again, we're not looking to get points that are on the line. We're looking, excuse me, that are data points. We're looking at points that are on the line. Will I move that at all? Will it let me move it? Yeah, I'm going to move that, see if it can let me move it. I think if I move it a little bit that way, it's better. Okay, so points on the line. I've got a couple data points that are on that line, or I can pick points that cross at the corners. So like here is a point that crosses at the corner. And then here I have a data point, so I'm going to use that data point. So that would be 66, 131. And then the other point is 69, 144. Does that make sense? Okay. So now when we write the equation of our line, what do we do next to find that equation of the line? It's the line of best fit. So we're going to find our slope first, just like what we've been doing before when we had 2 points. So we're going to find our slope. So y2 minus y1 over x2 minus x1. So 144 minus 131 over 69 minus 66. We get 13 over 3, which is about 4.33. So, Rustin, where does that 4.33 go in our equation?
The slope.
Yeah, so it would be in place of m. So 4.33x plus b. And so now what do we do to find the b? Take a point. That's right. Good. So either point, doesn't matter which one you choose. Let's choose this first one. So we're going to put a 131 in place of the y, and then a 66 in place of the x. So we get 131 equals 285.78 plus B. So we subtract 285.78. And we get B is negative 154.75. So now we can write the equation of our line using this here. So we have y equals 4.33x minus 154.75. So we just computed our line of best fit. So now we're going to have a couple questions here, make some sense of this. So does it make sense that we have a positive slope? They're looking at that graph. Yeah, positive, isn't it? And then does it make sense that it's going to cross, if you take a look at the way this looks, down somewhere at like negative 154, somewhere down there, it'll cross. Hopefully that you can see that that makes sense too. So yeah, it makes sense. So our equation is y equals 4.33x minus 154.75. And then we want to find, predict the weight of a sand shark whose length is 75 inches. So where do we put the 75? In place of the x, because the length is are your x values. So we're going to use y equals 4.33 times 75 plus 154.75. And we get 479.5. Wait a second. Oh, sorry, I computed it wrong on my calculator. Let me do it again. I added instead of subtracted. This is a minus. And that gives us 167.75. So we can round that up to about 168 pounds. Well, if we're talking about how much someone weighs, I mean, you don't have to, but we might usually round that 169 pounds. Okay, last question. It asks about what does the slope mean in this situation. So on your quizzes, this was the most often missed problem. I think it was the hardest question on that quiz. So if you remember, I talked about when on that slope, I want to see the word increase or decrease. I want to see that again here. So will this slope be an increase or a decrease? Okay, so there's an increase. And then we want to name what our slope is. 4.33. And then we want to use our units. 4.33 is the same as 4.33 over what? 1. Does that make sense? So, these are our y's on the top. So if you look at your y's in your table or on your graph, your y's are which? The length or the weight? So it's 4.33 pounds per 1 inch. So there's an increase of 4.33 pounds per inch. And if you can just say inch or inch in length. So when that length is increasing by an inch, the pounds increase by about 4.33. Does that make sense? So